This video is for class 7 physics, and in this video we are studying about the effects of heat. The heat produces mainly the following three effects. Number 1, the change in temperature of the body. Number 2, the change in size or shape of the body, and number 3, the change in state of the body. Let us discuss these points one by one. Now coming to the first point, which says the change in temperature of the body. So when a body is heated, its temperature rises, and when the body is cooled, its temperature falls. Now the question arises, why? Because when we heat a substance, the internal energy of the substance, to be specific, the internal kinetic energy of the substance increases, therefore the temperature rises. And when it is cooled, or suppose when you put it in the refrigerator, the internal energy of the substance decreases, right, and therefore its temperature also falls. Now the change in temperature of the body, either you increase the temperature or you decrease the temperature, depends upon following two factors. Number A, the quantity of heat imparted or rejected from the body, and number B, the material of the body. Okay, let's try to understand the first point. The quantity of heat imparted or rejected from the body, it means that more you give heat to the substance, more the temperature should rise, and more you extract the heat from the substance, the temperature should fall, right, with a greater amount. Now coming to the next point, which is number B, the material of the body. Okay, the material of the body. Let us take this example. Let us consider two substances, one iron, okay, the other is copper, right. Suppose they are of same mass and we are giving heat to iron about 100 joules, and we are giving same amount of heat to copper, which is also 100 joules. Suppose both of them are at 20 degrees Celsius. Okay, now this copper will rise its temperature faster, more, okay, compared to iron. Okay, compared to iron. If copper reaches 22 degrees Celsius, okay, 22 degrees Celsius, the iron might reach 21 degree Celsius, little bit less than copper. So this will explain that different materials requires different amount of heat to rise its temperature to the same extent, okay, provided they are of same mass. Now so basically here the change in temperature depends upon two things, that is the quantity of heat and the material of the body. So when the heat is imparted or given to the body, its temperature rises, okay, its temperature rises, while if heat is rejected or taken out from the body, its temperature should fall. Okay, I hope you have understood the first point. So coming to the next point, which is point number 2, the change in size of the body. When a body is heated, it expands, and when the body is cooled, it contracts, right. When the body is cooled, it contracts. So the change in size of the body is due to the heating, is called thermal expansion. We have to do this thermal expansion in detail, okay, afterwards in the same chapter. Now coming to the last point, which is point number 3, the change in state of the body. The matter exists in 3 different states, namely solid, liquid and gas. The process of change from one state to the another at a constant temperature is called change of state. Now as you all know, this is solid, right, this is liquid, right, and this is a gas. So when you give heat to the solid, it will change into liquid when you heat it, and you heat liquid, it will change into gas, right, and when you extract heat from the gas, it will change into liquid, and you extract heat from the liquid, it will change into solid. This thing probably you have studied in class 6 in chemistry, right. Now let us understand this thing in more detail. Now they are saying the process of change of one state to another. Your one state to another means solid to liquid, liquid to gas, gas to liquid, or liquid to solid, etc. at a constant temperature. That means whenever the state is changing, the temperature should not change, it should remain same. It's called the change of state. So here by this statement we also understand one more thing, that is when we heat a substance, suppose this is a substance, when we heat a substance, right, when we are heating a substance, then what will happen is either the state changes, okay, either the state changes, or I can say, or temperature changes, or temperature changes, right, either the state changes or temperature changes. These two things, change of state and the change of temperature, cannot occur simultaneously, cannot happen at the same time, okay. Now when a solid is heated, it changes into its liquid state at a fixed temperature. This process is called melting. So whenever solid change into liquid, right, the process is called melting, and probably it should happen at a fixed temperature. The reverse happens, that is when liquid will change into the solid state, it's called freezing, right, when liquid freezes into the solid at the same temperature, right, at the fixed temperature, is known as freezing. The process is called freezing. For example, ice at 0 degree Celsius on heating melts to water at 0 degree Celsius. That means when we take ice at 0 degree Celsius and give heat to it, okay, then it will melt into water, which will also be at 0 degree Celsius, right. So here you can see the temperature did not change, the temperature was constant, the temperature did not change while the state was changing. But if we reverse the process, while water at 0 degree Celsius now on cooling freezes into ice at 0 degree Celsius, right. So here also the temperature remained constant whenever the state was changing, right. That is one thing. The other thing, what we can understand from here is the melting point and the freezing point are same for a given substance, right. For example, ice melts at 0 degree Celsius and the water freezes at 0 degree Celsius, right. So going to the next paragraph, when a liquid is heated, it changes into its vapor or gas at a fixed temperature. This process is called vaporization or boiling. Now the reverse happens when the vapor is cooled. The vapor condenses into liquid at the same fixed temperature like before, okay, like water was getting freezed into ice at 0 degree Celsius and the ice was also melted at 0 degree Celsius. So here there are two processes, one is the boiling or vaporization, the other one is the condensation, right, the reverse process of this. Now for example, water at 100 degree Celsius on heating vaporizes into steam at 100 degree Celsius. So here change of state is taking place at the same temperature, while the steam at 100 degree Celsius on cooling condenses into water at 100 degrees Celsius. So here both the temperatures are same, that means the change of state is taking place at the same temperature. And the other thing is that the boiling point is 100 degrees Celsius, right, and the condensation point also will be 100 degrees Celsius, right, if they are pure, okay, if the substance is pure, if the water is pure. Now going to the next point, when like next paragraph, when a solid on heating changes directly into vapor at a fixed temperature. Solid can be changed into gas, okay, directly without going in the liquid state, right. The process is called sublimation. For example, camphor on heating changes directly into its gaseous state. The change of state from the liquid to gas at all temperatures is called evaporation. This is quite different from others, okay, this process, evaporation. Why it is so different? Because it does not have a melting point, boiling point, evaporation point, etc. It takes place at all temperatures. The change of state from liquid to gas at all temperatures is called evaporation. Thus evaporation differs from boiling, right. Evaporation is also like a change of state of the liquid to the gas, but here it can take place at all temperatures. Boiling is at a fixed temperature. while evaporation takes place at all temperatures. This is the first difference between boiling and evaporation. For example, drying of clothes is due to evaporation of water. Evaporation is a slow process, okay, whereas boiling is a rapid process. This is another difference between evaporation and boiling. Figure 5.6 shows the change in different states of matter. Let us go through this figure. Okay, here we can see solid, liquid and gas, right, and the different processes involved in the change of state. Now when solid will change into the liquid state, the process is known as melting, and it can be done by the absorption of heat. When you give heat to the solid and solid absorbs heat. Now liquid can be changed into the gaseous state, okay. The process is known as vaporization or boiling. It happens when the liquid absorbs heat. Now gas can be changed into the liquid state. The process is condensation, and it happens by the rejection of heat energy. When gas liberates, takes out, okay, heat energy, then it can change into liquid state. Liquid also can change into the solid state by the rejection of heat energy, and the process is called freezing, right. And there are two more processes. Solid directly getting changed into the gaseous state, the process is known as sublimation, right, and the gas can directly change into the solid state, and the process is known as solidification, right, without going in the liquid state, right. You cannot see evaporation here because all this change of state takes place at the fixed temperature, whereas evaporation is a special one which happens at all temperature, and it is the process of change of liquid state to the gaseous state only. Okay, let us go to this activity, that is activity number 3. Going to this activity, that is activity number 3, to show the melting of ice, right. Take about 200 to 300 gram of crushed ice in a 500 milliliter of beaker. Immerse a thermometer in ice and note its temperature. Heat the beaker containing the ice from below and record the temperature after every 30 seconds till the ice melts. Continue to heat the water and record its temperature for 5 minutes more. Record your observation in the following table. Okay, let's see what happens. Okay, now from your experience, what should happen? Okay, obviously the temperature of the ice should rise, okay, and the ice should melt at a fixed temperature which is at 0 degrees Celsius, right, and then it will change into water at 0 degrees Celsius, okay, right, and the water starts heating up. The temperature of the water should rise and starts boiling at 100 degrees Celsius. So let's see what does the book wants to say. From the above table, you will notice that the temperature remains 0 degrees Celsius till the whole ice melts. This should be done in the lab actually. Okay, so though heat is continuously supplied to ice during this period, its temperature does not rise or does not increase. Okay, the heat supplied during this period is used up by the ice in changing the state from solid to liquid, so the temperature will not change, as we have discussed earlier also. Once the ice is completely melted, the temperature of the water begins to rise. So until unless the ice does not melt completely, the temperature should be fixed at 0 degree Celsius. The temperature at which the substance changes its state from the solid to the liquid state, that is the melting, is called melting point. Okay, it's called melting point. Thus melting point of ice is 0 degrees Celsius. For different substances, the melting points will also be different. Okay, so this much for this video. Thank you so much.